Hello, welcome to chapter 3, and we are talking about increasing, decreasing intervals today in our section 3 of this chapter. So we're basically looking at graphs first. And if we pretend we have a graph something like this, then we want to be able to tell where, like what sections of this graph is it increasing, is it decreasing, is it constant? So those are your three options. You're either increasing, decreasing, or constant. Now, in the previous two sections, we talked about critical points and maximums and minimums. So if you look at this graph here, we've got a couple. There's a relative maximum here and a relative minimum here because it's like the topmost part of the hump, the bottommost part of the hump. Now, when we talk about increasing or decreasing intervals, remember, whenever we read, we go from left to right. So looking from the left side of the graph, heading towards the right, you can see as we follow the graph, it's going up first. And if you want to get even more technical, if we were looking at like at this point right here, the tangent line, if we drew a tangent line right there, it would go somewhere over here with a positive slope because it's going upwards. So anywhere where the slope of the tangent line is positive, that counts as increasing. So then the opposite would be true as well. If the slope of the tangent line is negative, then that section of the graph would be considered decreasing. And so basically you would see that it switches direction every time you have a relative maximum or minimum, because you're going up, 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 up here until you get to the maximum, and then you start going down until you get to the minimum, and then we change directions again and we start going up again. So now that's increasing until finally we have this section of the graph here where it's just flat. The slope of this section of the graph, if you were to draw a tangent line, the slope would be 0 because it's a perfectly flat line. So this would be considered constant. Okay, so in a graph, this is pretty easy to see whether it's increasing or decreasing or constant. So now we want to be able to do this with just an equation and not actually having to graph it out because, that just takes too long. So with an equation, what we want to do then is to look for those critical values again, so that we can see where it's going to change directions if we were to graph it out. And then that means everything in between those critical points then would be the spots where it's either increasing, decreasing, or constant. Then we can test out the derivative, whatever the derivative is. If we end up with a slope that's positive, or greater than 0, then it will be considered increasing. If it's negative or less than 0, then it would be decreasing. If it is 0, then it's just constant. So let's do a quick example. We've got the function f of x equals x cubed minus 3/2 times x squared. And we're going to find the intervals of increase and decrease. Okay, so first thing we want to do is basically figure out where does it change direction. So we want to find those critical points. And if you remember from our previous videos, finding those critical points, you're going to find the derivative and set it equal to 0 to solve for x. So our derivative here is going to be 3x squared minus 3x using the power rule. So we're going to set that equal to 0, and we want to solve for x to find those critical points. So solving for x, I'm going to factor. To solve, I can take out a greatest common factor of 3x, and that'll leave me with x minus 1. So setting both of my factors equal to 0, I have 3x equals 0, so that means x equals 0, and then I have x minus 1 equals 0, so x equals 1. So my critical points are going to be at 0 and 1 for my x values, which means if I were to graph this out, that means at x equals 0 and x equals 1, I either have a relative maximum or a relative minimum there, and those would be the spots where I'm going to switch directions. Remember, when we find critical values, you also want to test out if there's anything where you're going to have like sharp turns, discontinuities, anything like that, because those also count as critical points. So here we just have a polynomial function though, so there's nothing there with like vertical tangent lines or anything like that. So our two critical points are just the 0 and 1. Okay, so now that I have the points where it's going to change directions, now I need to figure out for the rest of the graph then, like everywhere else except for those points, is it increasing or decreasing? So what we're going to do to kind of like help us organize our thoughts here is to kind of make a number line. So it's kind of like us graphing this out without actually graphing it. So on my number line, I'm just going to put my critical points on it. So my two critical points were 0 and 1. And then I want to figure out then in all the sections in between the 0 and 1, like between 0 and 1, on the outside of the 0 and the 1, are all those places going to be increasing or decreasing? So to figure that out, we were saying increasing and decreasing is when the slope or the derivative is greater than 0 or less than 0, depending on whether it's a positive or negative number. So that's what we're going to do then. So we're going to figure out points that we can use to just plug in to the derivative. So x values, we're basically saying like, okay, let's pretend at x equals -1, because that's a number that's smaller than 0 here. At x equals -1, the slope at x equals -1 would be found by just plugging in -1 into my derivative. When I do that, that'll tell me whatever number I get is going to be the slope. We just want to know if that slope is going to be positive or negative. So plugging in x equals -1 into my derivative of 3x squared minus 3x, I get 3 times -1 squared minus 3 times -1. So that's gonna be a positive number because I get positive 6 from that. So if I get a positive 6 here at x equals -1, that means to the left of the 0 that I had, my critical point of 0, everything on the left of it is going to be increasing because it's positive. Okay, so now we're just going to do this for the rest of the sections that I have. So between 0 and 1, I just need to choose a number between 0 and 1 that I can plug into the derivative. I'll go with 0.5. Why not? So you can choose any number as long as it's not 0 or 1, and it's got to be in between. So plugging this into my derivative, I end up with, I'm going to work in fractions here because my brain. I think I get -3/4. It doesn't matter what the number is. We're just looking for whether it's going to be positive or negative, and I end up with a negative number. So that means between 0 and 1, it's going to be decreasing. Okay, and then my last section is anything to the right of 1. Well, I just need to pick a number that's greater than 1, so how about 2? So plugging that into my derivative, I end up with 3 times 4 is 12 minus 6 is a positive number. And again, I don't actually care what the slope is. I just need to know whether it's positive or negative. So now I have like a nice little visual here. So 0 and 1 are my critical points. This is where it changes directions. So that means everywhere else is going to be either increasing or decreasing. So writing this out then, I'm going to have my intervals of increase from -infinity to 0, and from 1 to infinity. So basically I'm saying everything to the left of 0 and everything to the right of 1 is where it's increasing, because that's where I got those positive slopes. We want to make sure we're using like regular parentheses for those numbers though, because remember at 0 and 1, that's where it's constant. That's where the derivative is equal to 0, because that's where it changes directions. Those are our critical points. So they don't actually get included in the part where we're saying it's like increasing or decreasing. So whenever you're listing out your intervals of increase or decrease, the numbers themselves, the critical points, always get a regular parentheses. And then lastly, our interval of decrease is going to be from 0 to 1. Everything in between are 2 critical points. And that's it. All right, so in general, anytime that we're asked to find increasing or decreasing intervals, you want to first find your critical points. So set your derivative equal to 0, solve for x. Then make your number line, put the critical points on there, and then plug in values around the critical points into the derivative to see if you're going to get a positive or a negative number. And then the positives and negatives will tell you the increasing or decreasing intervals. All right, let's do another example. So this time we're going to use the function f of x equals x plus 9 over x. So our first step is to find those critical points. So I'm going to find the derivative. Actually, before I even find the derivative, I'm going to rewrite this a little bit because I don't want to use quotient rule for the 9 over x. So I'm going to rewrite this as x plus 9x to the negative first power. That way I don't have to do quotient rule. You can if you want, I just don't prefer. Because now I can just use the power rule. So the derivative of x is just 1, and then the derivative of 9x to the negative first power, I can use the power rule, bring down multiply the exponent with the 9, and then decrease the exponent by 1. Okay, let me rewrite this so that I don't have negative exponents. So this will just turn into 1 minus 9 over x squared. Okay, so there's my derivative. Set it equal to 0 so that I can find my critical values. Let me subtract 1 to both sides. Divide by 1. And multiply both sides by x squared. So I'm going to get x equals plus or minus 3, because when you square root both sides, don't forget you need that plus or minus. Okay, so I've got 2 critical values so far. Don't forget you also have to check, like in your original derivative, do you end up with anything, or sorry, not even your original derivative, but also the original function. Do you have any discontinuities? Do you have vertical tangent lines, sharp turns, anything like that? So if you look at our original function and we have x plus 9 over x, we're dividing by x. So remember there's that rule where you can't divide by 0. So that means x can't be 0. Because you'd end up with a vertical asymptote there. So that means at x equals 0, this also counts as a critical point. Okay, so these are the things you have to pay attention to. It's not just like when you just solve for x, you also have to look at the original function or even the derivative. Okay, so now I'm going to make my number line, use my critical points. So I've got -3, 0, and 3. And I know it seems kind of obvious, but I don't know, sometimes people think in weird ways. Make sure it's a number line, so your numbers have to be in order by like smallest to biggest. Okay, thought I'd just mention that. All right, so now we want to plug in values around our critical points into the derivative. So that means I need something to plug in right here, right here, right here, and right here. I'm just going to pick numbers, whatever your heart desires. I'm going to go with a -4, -1, a 1, and a 4 here, because those are the numbers that are in between. But again, you can pick, like, if you wanted to pick -2 in between the -3 and the 0, that's totally fine. Up to you. Okay, so plugging in -4 into my derivative, I end up with 1 minus 9 over -4 squared, 9 over 16, and then subtracting that from 1, I end up with a positive number. Plugging in -1, 1 minus 9 over 1 is going to be negative. 1 minus 9 over 1 squared is still negative. And 1 minus 9 over 4 squared is going to be positive. Okay, there we go. Got my pluses and minuses. That means we're going to be increasing from -infinity to -3, because that's that first positive section here. And then we write the little u to like connect, or like to tell people there's also this other spot where it's going to be increasing from 3 to infinity, because it's talking about everything over here in this section. Okay, and then decreasing. So for decreasing here, we have 2 sections, from -3 to 0 and from 0 to 3. And I know it looks like that they're connected, but remember that 0, because it's a critical point, that's neither increasing nor decreasing. So you still have to write it out as -3 to 0 and from 0 to 3, even though it looks like there's 2 sections in a row that's decreasing. But you still have to split them up with that 0. Okay. So there's my other example of finding increasing or decreasing values. The last thing I want to talk about in this video is the first derivative test. So the first derivative test is basically just a quick test to identify whether your critical points are maximums or minimums. It's really easy. We're basically just going to do what we just did with finding increasing, decreasing intervals. And then we're looking at that number line where we have the pluses and minuses to basically tell us whether it's going to be a maximum or minimum at those critical points. So in your number line, if you see going from left to right, a minus to a plus sign, this is going to be a relative minimum at the critical value that's in between. Because if you think about it, you're decreasing because negative, then you're increasing. So whatever point you had in between, that critical point is going to be a minimum. So then the opposite way, if we're increasing first, so a plus sign to a minus sign, so then decreasing is going to make a relative maximum. And then if you have a plus to plus or a minus to minus, that means you're increasing and then increasing again, or decreasing and then decreasing again, but there's like a weird point in the middle where it's neither. That would look something like this. So I'll kind of like roughly draw it out. Like this would be plus, and then like there's a critical point there. So increasing to increasing again, or decreasing to decreasing again with like a critical point right there. So as you can see, that makes neither a minimum nor a maximum. So that's why it's neither. But once you've made your number line and plugged in all your values into the derivative, you'll see your pluses and minuses, and then you should be able to tell whether these are going to be maximums or minimums without actually having to do your like XY chart that we used to do. So that's it for this section. I've taught you everything I know about your increasing, decreasing intervals and your first derivative test. So see you next time on your 3.4 video. Bye, thanks for watching.